Hi guys, this is Ms. Griffin. We're looking at Unit 11, Skill 1. So we are jumping into a brand new unit where we are going to talk about probabilities today. And mostly we're going to talk about probabilities in two-way tables. So here's your essential question. Pause your video so you can write it down. How do we find various probabilities from two-way tables? So because this is a first brand new skill, you've probably not talked about probabilities since maybe 7th grade. And this is a little bit different than what you've done. You did basics in 7th grade, and we're going to expand on that. So we are going to have a lot of vocab and a lot of symbols and things to write down off to the side. So this video might be a little bit longer, but just pay attention, pause it if you need to, rewind, etc. Use your strategies and your skills to make it through this video and to actually understand it. If you do have questions throughout the video, jot them down. Okay, so don't just sit here not understanding, jot down your questions, watch through the video, and then ask us next class. All right, so we've got a two-way table. A two-way table has categories here and categories here. Okay, that's why it's two ways. And we are talking about classifying students at Rufus King High School according to gender and whether or not they participate in an after-school program. So those are our two categories. We've got gender and participation. Okay, so now in order to do probabilities, we first need to assign letters to represent the events or categories. Okay, so let's do F for female, M for male, right? Pretty basic. And if you want, you can put them in parentheses, it doesn't matter. We will do, I don't know, A for after school, and NA for not after school. You can make up your own letters, but you want to make sure you label them. Okay, and then in order to do probabilities, we actually need to have total on all the females, all the males, and then total on who participates after school and who doesn't. So I'm just extending my lines so that it's sort of nice and clean. So to find out the total of all the females, I need to total up the females that participate and the females that don't. So I'm just adding straight across to find out the total. To find totals, you just add. Nice and easy. Okay, so this gives me 580 over here. And then I'm going to do the same thing for males. So 168 plus 252 is 420. And then to find out the total number of students that participate in the after-school program, I have to add up the females and the males that do participate, put my total here. Same idea with over here. Do not participate, add these two up, put my total here. And then we'll talk about this blank spot in the end. So I have 400 and 600. And then for this blank spot in the end, I call this the total. It sounds weird, but it's like the total here and then the total here. Total. And so I just have to, again, add up either straight across or straight down. And I actually want to do both of them to double check that the number is the same. If the number is not the same, then I did a little bit of math wrong. So I add up across and I get 1,000. I add straight down and I get 1,000. So there are 1,000 total students that were being surveyed here. Okay? So it says, what is the probability that a randomly selected student is male? So before we get into actually finding the probabilities, we're going to write a couple things down on the side. So the first thing I wrote down was just find the totals by adding, just as a quick reminder for us if we forget how to do it, come back to our notes and then it's right there. Okay, so we're going to use this notation moving forward with probability for the rest of this unit and future units if we touch probability. So here we have this P and then parentheses. You put something inside this parentheses and it would normally be one of your letters. So for example, when we do this first part A, it says what's the probability that a randomly selected student is male? So I want to know the probability of means parentheses. Probability that the student is male. So the event goes inside here and we're talking male, so that's my M. Probability of the student being male. And then here, I put either a fraction or a decimal, depending on what kind of numbers we're working with in our table. If these are all whole numbers, then you end up with a fractional answer. If these are decimals, then you can either A, end up with a fractional answer, or B, end up with decimals. And we'll see that in a later example. Okay, so probability of being male. Well, I have to look at the possibility of being male in general. I could be a male and participate after school, or I could be a male that doesn't participate after school. So these two, remember, if you recall, we added these up to make the total number of males. Well, there are 420 males out of a total 1,000. So the probability of being male is that 420, all possible males, out of all possible students. And there we have it. We're going to leave it just like that. We're not going to reduce it. We're not going to do anything to it. We're just going to leave it because we love to be able to look right back at our table and say, oh yeah, the 420 came here and the 1,000 came here. Okay, so just leave it exactly the way you see it. And if you want to write a note, you had to put this out of all students. Okay. So we've got a second probability here that says, what is the probability that a randomly selected student is female? And that's a key word here, we're going to talk about that, and does not participate in after-school activities. So first let's write this out in words. Probability of female, and what was our symbol for not participating? NA. Okay, now I am going to give you a special symbol for the word and because mathematicians are super lazy and we just want to use symbols all the time. Okay, so I'm going to write it down. You're going to pause your video when you're ready to write it. Okay, so what I wrote here is that the and symbol, so literally every time you see the word and, you should be thinking this symbol. It looks like an N, and there's a little trick. There's an N in the word and this looks like an N, but there's no like stem. Okay, so it's just the upside down U. You're going to find where the two events meet. So we're talking about females and not participating after school. So I find out where those two events meet. Females not participating. So 348. Female and not participating after school. And then we put it out of total. Because we're talking about all the students in that school that were surveyed. There are 348 of them that are both female and don't participate after school out of all of them. Okay, so this symbol would get used like this. Probability of F and not participating after school. Okay. Now normally we write this on this side, I just didn't want to squish it. And this was our final answer up here, so I'll box it in. Okay, part C. What is the probability that a randomly selected student is male? Okay, so that's our first event. Or, here's another keyword, or participates after school. So I'm going to write stuff down about the word or and its symbol, and then we'll get moving forward on how to actually find the probability. All right, so the or symbol is actually a U shape. So again, the trick to remember the difference between the two is that and has the N in it, so the symbol looks like an N, and or is the upside down, or sorry, the right side up U. So to find the or, we actually have to do this little calculation. It's not hard, and you'll get used to it the more you use it, but we take total 1, add it to total 2, and take away the and, the intersection of the two. So let me explain to you using our actual table and the two events we're talking about. So we're talking about all the males. Let me grab a highlighter. So we're talking about males or participating. Notice as I covered over that, I hit this spot twice. I hit it as a male and as a student that participates. So what we want to do is make sure that we add up this spot here, the total of students that participate after school, this spot here, the total students that are male, and then take away one of these intersections where they meet each other, participating and being male, because I've hit it twice. In the 400, I hit it once because I totaled these up, going straight down. And in the 420, I hit it once because I totaled, again, going straight across. Again, this spot got hit twice, and we can't have it in there twice, otherwise we're double counting. Okay, so I take my total participating, my total male, and I subtract away the intersection, the and part of this, being male and participating after school. It doesn't mean that I've not counted it at all, because I have. I was just double counting it before I subtracted it off. So probability of male, I'm going to use my symbol right away, or participating after school, so that's the A. And I have to again do the addition here. So 400 total 1, plus 420, total 2, minus 168, that double counted intersection. And it's always out of the total. Ands, ors, and just a single event are always out of total. And this should be 1,000, not 100. And then I just simplify it. So it's 652 out of 1,000. Okay, so here, final answer. Add total 1, add total 2, take away the intersection, meaning the and part. Okay, then the last question here says, what does 168 out of 1,000 represent in the table? So I'm going to find out where that 168 is. I know my table's crazy marked up right now, but if I grab a different color, maybe we'll be able to see. So 168, it's that one I circled a million times. 168 out of 1,000. Okay, so this 168 is coming because this person is a male and participates. Okay, so it's probably the probability, that's how we always start, probability of being a male and participating after school. The reason I know that it's an and is twofold. A, it's, I didn't mean to draw that bright pink line there. It's the intersection of these two right here. And B, it's out of the total. Okay, so it's just one number found in the table out of the total, and it was where the two parts meet. That's an intersection called the and. All right, flip it over. You guys are doing great so far. Have faith. So this is actually the same exact table that we had. It's just that we've already filled in the 400, 600, and all the other totals. Okay, you guys see those here. 600, 580, and total of 1,000. So now we're going to talk about these things called conditional probabilities. So this is where the conditions are restricted. And what we mean by this is that a fact, and this is going to sound weird, but a fact is given or known. So we're going to talk about the symbols, what it means, and then how to apply it. So we're going to see symbols like this, probability of A, and then there's this big bar, and then another event. So it doesn't have to be A and B, it just has to be whatever our events are, or our categories with their labels. But I want you to write this down over here off to the side, that if it says probability of A bar B, that bar literally means the word given. Okay, so we're going to write this out. P parentheses A bar B is not how you say it. You say it as probability of A given B. Now there is a special formula to find this, and I'll write it down, but I'm going to tell you that we're not really going to use it or apply it, okay, because it makes things a little bit confusing. But this is the formula in case you ever have to know it. Probability of A and B divided by probability of B. Okay? But like I said, we're going to do this in a slightly different way where you don't have to use the formula. So it says, what is the probability that a student participates in an after-school program given that they are male? So here's our known fact. Sometimes it will explicitly say the word given, and that makes your life really easy, and other times it won't. And you'll have to interpret the question based on the wording. All right, so I just wrote this little think question down over here because that's going to help us to understand where some of these numbers and things are coming from. So it says think. Out of all the males, because again, we know that this student has to be a male, how many of them participate after school? So I'm going to first write down my symbols, probability of. Now remember that this bar means given, and then what the given or known fact is goes here. So probability of something given that they are male. And the of something part that I just mentioned is the after school program. So that was our A. Probability that they participate after school given that they are male. So this always results in a fraction. And we want to say out of all the males. So the out of part goes on the bottom. Out of all the males, well, all the males is 420. Out of all of those males, so whoa, cool. Now I get to just focus on this row only because I'm talking about out of all the males. That's it. Okay, you can even think about like getting rid of this section and getting rid of the not participating section. But I want to focus going across because we're talking about all the males. Out of every single one of those males, how many participate after school? Well, out of all the males, the only ones that participate are the 168 of them. And that's your probability. So let me just recap what we just did because that seems maybe a little confusing. Actually, let me try to erase this. So again, we said that we are given a male. So I'm going to highlight that row, focus only on that row for a minute. We are given males. And out of all of the males that we have, 420, how many of them actually participate in the program after school? 168. Okay, so we're going to do 2 more conditional probabilities so that you can get more practice with it. I'm just going to zoom out a little bit. What is the probability that a student is female given that they participate in the program? So here's our known fact. I'm going to write down my symbols, and then I'm going to write down the think question. Try to come up with the think question on your own based on what you see here and what we saw in the previous example. Probability, we know that it's given that they participate, so A goes in the back spot. And we're talking about the student being female. Female given that they participate. All right, so here's my think question. Out of all participating students, because again, we know that they participate, how many of them are females? So now I'm going to look back at my table. I'm going to erase my highlighter, if I can. Okay. So now I'm focusing on all of the students that participate. Let me get a different color. All the students that participate right here, this row. And then I only want to care about the females. So females out of everyone that participates. All right, nice and simple. 232 out of 400. And I want to point out to you something that maybe you didn't recognize in the first example. All the males started after the given bar, right? And then they go underneath the fraction bar. So whatever you put in the back goes on the bottom. Whatever you put in the back, participating, goes on the bottom. All the students that participated were 400, goes on the bottom. Okay? One more example of this and then we're going to move on. If a student is female, what is the probability that they do not participate in the after-school athletic program? So I don't see the word given in this, but nor do I see the word and, nor the word or. So I know that this has to be a conditional probability where I use the bar because there's no and, there's no or, and there's 2 events. We know that this is female and they don't participate. But again, it's not an and because it doesn't say and, so disregard the fact that I just said the word and. It says if a student is female. So, whoa, this student has to be female. This is known. So given that the student is female, what's the probability that they do not participate? So not after school. Okay, so I'm going to write my think question real quick. I like writing these think questions, or at least thinking about the think questions, because it helps me to find exactly where I want to be in the table. So I want to be thinking about out of all, and then I have to fill in the blank. How many? Blank. So we're talking out of all females, because that's what's given. How many do not participate? Okay, so let's go back up to our table. We're talking out of all the females. And when you're doing this on your paper, if you don't have highlighters or erasable highlighters, they do exist, by the way. Friction is a brand that has erasable highlighters, and they are amazing. Anyways, if you don't have an erasable highlighter, you can use just your fingers or pens. Like not write on here with pens, but use your pen to cover up this column or to box around this column or something like that, whatever it is that you're focusing on at the time. So again, this one, we know that the student is female, so I'm going to highlight this row because that's my only focus. So now what I'm saying is if you have something besides like erasable highlighters, you just cover up the other sections so then you don't focus on them. And then you're solely focused on the female row. You wouldn't use a nice arrow like this. I didn't know it was an arrow when I picked it out, but anyways. Okay, so I'm focusing on all the females, and I want to know out of all the females, so total number of females, how many of them do not participate after school, and that's this row. Well, sorry, that column. So out of 580 females, 348 of them do not participate. So I make my little fraction. Remember, the second thing goes on the bottom, that's the females out of all of them. It should always be the bigger number on the bottom. Okay, if not, then you've done something wrong. Bigger number on the bottom. So out of all the females, that goes down here, how many don't participate? Well, that was 348. Box it in, that's your answer. Okay? One more page where we've got a mixture of symbols and words, and then that's it. All right, this table's looking a little different. If you haven't noticed, there are decimals here. And we've already got the totals written in. Sometimes they are given to you, other times you have to find them. If you wanted to find them yourself, you just add straight down. 0.12 plus 0.3 gives us 0.42. Okay? Or add straight across. But one thing I want you to notice is that every time you have decimals, the total is always out of 1.0. So I'm going to write that off to the side. Okay, so as I just said, probabilities as decimals, then your total is out of 1.0. All right, so they say let A be students with asthma. So wherever I see that category on my table, I'm going to put A. And let S be students that have at least one household that smokes. So now you'll notice that right here we have this other symbol, A, and then it has that apostrophe next to it, but it's actually read as A complement, meaning not in set A. So that means when we have not have asthma, that's A complement. And not smoking household, that's S complement. And one thing you guys need to recognize is that the probability of A plus the probability of A complement always equals out to 1.0. And we're going to see that in this first example with A and B. Okay. So, probability of A, well, they already gave us a symbol, so all we got to do is come up with a fraction. So, the probability of being a student with asthma, out of all the students that were surveyed, what's the probability you have asthma? So, all the students that were surveyed is our total, that 1.0. And then the number of students that have asthma out of all of them is the 0.19. Now, there's different ways that this can be written. Because it's just out of 1, it could be written as 0.19, or it could be written as 19 out of 100. I just slide the decimal, boop, boop, 2 spaces to the right. Okay? So either way is fine, but don't leave it with a decimal on top and a decimal on the bottom. That's really ugly looking. Okay? We don't like ugly. So 0.19 is my final answer for probability of being a student with asthma. Probability of being a student without asthma, A complement, so meaning the student does not have asthma. Well, that's going to be the 0.81. Total number of students without asthma out of the 1.0. And again, because it's just out of 1.0 or out of 1, then it's just 0.81. Or I could write it as 81 out of 100. And here's where I was talking about the probability of A and A complement. These two numbers add up to a total of 1.0. Okay, that should always happen because you're taking what's in A and what's not in A, and that should total up to 100%. Okay? So then it says probability of A, and then there's this symbol. Remember that symbol means and. Probability of A and S. So let me just erase this stuff on here, except for my symbols. I actually want to keep those. Okay, probability of A and S. So remember that and or and single events are always out of total. Probability of A having asthma and S being in a smoker household. A is here, S meets here. They meet, the intersection is 0.12. Probability of having asthma and being in a smoker household. And again, I just simplified that one because we don't like decimal over decimal. And because it's just out of 1.0, I can just simplify it to a single value, numerator. All right, the next one, this U-shaped symbol, remember, means and. False. It means or. I was writing or and then said and. Okay, so this is where we have to do the add two parts and then take away the intersection. So this is going to look like probability of the first event plus the probability of the second event, and then take away the intersection. Probability of A and S. Okay, so let me show you that again on the table with some highlighting. Probability of having asthma and probability of being in a smoker household. Again, see how I highlighted over this 0.12 twice? So I should be taking 0.42, adding it to 0.19, and taking away 0.12 because that was double counted. So 0.42, 0.42 plus 0.19, total 1 plus total 2, take away the and, the intersection. And so what this comes out to be, again, out of 1.0, because it's an or. What this comes out to be is 0.49 out of 1.0, so just 0.49. And again, the or has to do the subtraction because I double counted this 0.12 when I read downwards and read across. Okay? And last but not least, we've got this conditional probability before we move on to solving the word ones. So this says probability of A, and then there's this bar. Remember that bar means given S. So probability of A given S. So given S means I need to focus on just smoker households. Okay, so focus here. And it's A given S. So asthma given all the smoker households. All right, so let's write that out as a fraction. 0.12 out of all the smoker households. Don't know where that 5 came from. 0.42. 0.12 over 0.42. And again, we don't like decimals, but I can't just drop the denominator here because it's not 1.0. So what I'm going to do is write 12 out of 42. You can drop both your decimals and make it just a fraction. Okay? All right, so next it looks like we have some little word statements, and we just have to figure out our own symbols and what we're looking for. Probability that a student does not have asthma lives in a house with no smokers. So it doesn't say and, it doesn't say or. We got to figure out which one's our true fact. So I read this again. It says, what is the probability that a student that does not have, that's the known fact or given. So we're going to look back at our table after we make our little statement here with the symbols. So we have probability of something given something. So again, something given what we know. So does not have asthma has to go here. So that's A complement. And then we want to talk about the probability of a student living in a non-smoker household. So that's S complement given A complement. So when we look back at our table, we are given the fact that they are a student without asthma. So we're focusing right here in this row. And then again, we know that they are in a non-smoker household. Out of all the students that don't have asthma, how many don't live in a smoker household? So then those two become my decimals in the fraction, so 0.51 out of 0.81. Again, the non-asthmatic student goes on the bottom because it comes after the given bar, and then the non-smoker household goes on top. And again, just drop your decimals, and then you've got your final answer here, 51 out of 81. So if I erase that, we've got two more examples that should go pretty quickly for us. The next one says, what is the probability that a student that lives in a household with someone who does not smoke does not have asthma? So again, no explicitly given statement here, but if we read it, we can identify what the given statement is. Because again, there's no and, there's no or, so then it must be given because there's two events happening here. So what's the probability that a student that lives in a household with someone that does not smoke, so that's our given, does not have asthma? So probability, something given something, and we're talking about not smoking, so S complement, and then what's the probability that they don't have asthma, A complement. So this time, instead of highlighting the non-asthma column or row, I'm going to highlight the non-smoker row, or column, rather, because we're talking about the fact that we know that they are in a non-smoker household. So out of all the non-smoker households, how many have students that are not asthmatic? So we stick with the 0.51 because that was the common intersection point of A complement and S complement. But the denominator is what gets changed here because now we're focused on a different given or known true fact. So 51 out of 58. Okay, so hopefully you can see and identify the differences between these two. All we did was flip what was given and what was the questionable thing, and then now that adjusts the denominator. Numerator stayed the same, denominator got changed. Okay, sorry, I lied. There's two more now. Okay, so looking back at my table, I'm going to erase. And we're looking at H, where it says that we have the question, what is the probability that a student that does not have asthma, so that's given, lives in a household with someone who is a smoker? Okay, so try to write out your statement yourself here. Probability of something given something, and try to come up with your own fractions. Actually, do that for the next two. And then I'll put my answers on here and explain them. That way, if you are struggling, you can understand. Okay, so first off, here are my answers, 30 over 81 and 30 over 42. And then I'm just going to explain it for those of you that maybe struggled to get these same exact answers or you got them mixed up. So if you got it, then you're going to just move on to your practice. There's nothing else to do in the notes because the last page is just blank. If you didn't get it, pay attention. Okay, so here in part H, we're talking about S given A complement because we know that this student does not have asthma and we want to know the probability that they are in a house with someone who smokes. So given A complement, that's the non-asthmatic, and we want to know the probability of being in a household that smokes. So what I did was on my table, I focused on the A complement part. Oh, can't do that. So you can see that I highlighted in blue A complements row because I'm focused on all the A complements, the non-asthmatic students. So out of all of them, out of the 0.81, how many of them are in a smoker household? Well, that's 0.30. So my number becomes 0.30 over 0.81 and then drop the decimals, so 30 out of 81. Then the next one in part I has us looking at the probability that a student that lives in a household with someone who smokes, so given the smoker household, who does not have asthma. So given smoker, what's the probability that they are not asthmatic? So given smoker has to be on the bottom. Out of all the smokers, or all the people, how many are in a smoker household? Well, when I look back at my table, I first highlighted the smoker column, I know that there's 0.42 in total, and out of all of them, how many are not asthmatic? So that's this 0.30. So instead of looking across the row, I'm now looking down the column because this time I was given smoker as compared to last time I was given non-asthmatic. So again, this 0.30 is the same as the numerator, but the denominator switches based on the given statement. Remember, given statement is always what goes on to the bottom. I don't know why this keeps not moving. Okay, so hopefully I've explained it so that you can understand it. Again, you are going to get lots of practice with this. Please don't skip any practice problems. When you do your practice, make sure that you are writing the symbols out because you're going to have to know them and understand them in order to be successful on your final Algebra 2 exam in June. All right, let us know if you have questions. Otherwise, see you later.